Hello, myself Rishabh Raghuvanshi. In our cloud computing course, we have studied about Hadoop's MapReduce framework. So using HDFS MapReduce framework, I have implemented a program called WordCount, which counts the frequency of occurrence of each word in our dataset. So the dataset which I have chosen is a book called Alice in the Wonderland from Gutenberg. So we have three main topics which we are going to touch in this presentation. First of one is HDFS itself, second is its MapReduce framework, and third is the word count. So HDFS architecture is designed on the storage of less number of large files rather than storage of huge number of small files. On it, HDFS it is a distributed system, so data is distributed over several machines to be available for parallel computing. It is a master-slave architecture that there are two nodes which we call them as first of one is name node and second one of is the data node. Name node acts as a master and the data node acts as the slave. There is also a term in it which is a block. Block is the amount of data that can be read, minimum amount of data that can be read or written on the HDFS framework. So name node, its main work, it manages the slave nodes and assigns work to them. It also does functions like opening, closing, naming, renaming of files in directory. Secondly is the data node. These are the actual workers. They does the work assigned to them by the name node or the client. So they can also replicate themselves to create the maximum number of replicas as asked by the name nodes. So SDFS architecture provides us with many characteristics. Some of them are high durability due to the replication of data and high availability due to the distributed system. Now let us look at the MapReduce framework. So it is based on the idea of parallel, it is based on the idea of distributed computing. There are two main components in it. First one is a mapper and the second one is a reducer. So the work of a mapper is to read input from the HDFS file and it gives output in the form of key and a value pair. What this key and a value will be depends on what code the mapper is running. So before the output, that is the key value pairs, reaching to the reducer, there are two main works which are done, which is shuffling and sorting. So the work of shuffle is to shuffle all the output of the mapper so that the reducer get all the values corresponding to a single key, and it also sorts the keys in the order. So the reducer get input as a key and list of values, and it gives output as a key and a value. So what the output of the reducer will be, it also depends on what code reducer is running. So we have implemented the word count on the book. So in this word count, we have the mapper has read the input from the SDFS system, and it has outputted as the key and the value. So here value is 1 and key is the token. What this token is, we will define it in the code when I will be showing you the code. So the reducer input was key and all the values corresponding to those keys, which is a set of ones. The reducer's output is the key and sum of those values. So let me take you to the code. So the mapper's code, as you can see, we are taking the input as a text file, text. So we are converting it from text to string in the first line, and then we are using the string tokenizer function of the string tokenizer function. It is creating the tokens of the input string. So but we have used by default the delimiter to use for by this is a space. So if a space is between them, these are assigned as two different tokens. Now the mapper is creating the key and the value pair. So the key for each token, it is assigning it for each token, it is making it as key, and the value part is being assigned as 1, and the mapper is outputting this. Now after shuffling and sorting, the reducer gets the key and a set of values which is 1 1. So the code of the reducer is as such: it initializes a variable called sum to 0, then it iterates through all the values of a key and does the sum of those values and store it in the sum. As the reducer has got a single key with a set of values, so it is outputting that key with the sum which we have done on those values. So I have already run the HDFS MapReduce framework code, and so to know whether it is running right or not, in the input file I have inputted some random roll numbers, one of this which was mine. So as you can see, here is a snippet of the output. You can see my roll number 17 UCS 128. It has one occurrence on it. So now I will be running you through the code. So I'm running the command prompt as an administrator. So let me change the directory and reach where the SDFS file is stored. So where our SDFS file is stored, this is the location of our SDFS file. So let me just write it. So I have changed the directory. Now let me start the SDFS MapReduce framework. So as you can see, there is a data node, there is a name node. These all have started. So let me put them aside. So now I will be making a directory where the input directory in the SDFS system. So I think I have already made a directory name cloud. So let me change the name of it to something else. Now we will be inputting our input file, which is the Alice in the Wonderland text, into the HDFS system. So for that, there is a command. This is the location. This is the location of our file where it is located, and this is the input directory which we have created on HDFS system where we are inputting our file. It is taking some time. Now the file has been uploaded on the HDFS distributed system. So now the MapReduce code which I have written in Java, I have already compiled it and converted into an .zar file. So now I will be running it. I will be running the MapReduce on this file, input file. So I have it is in the input is cloud, and I have created an output directory called compute10 in which the output will be stored. So as you can see, the MapReduce will start running on the input file. You can see the number of running jobs it is showing. It will be taking some time to run. Oh, so now it has run completely. Now let me go to the output directory and show you the output of the program. So let's see the output. So, oh, there's some error. I think the command is wrong or something. Compute in this. So here we got the output. As you can see, there are various numbers with their output, and they are also sorted in the order, which is the function defined shortness of it. So let me see my roll number, which I have input in the text, whether it has the correct occurrence or not. So what numericals will be up somewhere. So here you can see the roll numbers. It's like 17 uses 128 is as the occurrence 1. Thank you.